So today we're going to solve rational inequalities. And the difference between what we did the lesson before this one is these were just basic quadratic expressions, polynomials. A rational inequality means that basically you have a fraction. So not only are we going to have an x at the top, we're also going to have an x at the bottom. And so this is a review of what we did right before this lesson. So what you would do first is you would factor. And you don't have to write this down, just watch me. And then 6 and 1, when you subtract, will give you the 5. So what we did first is we made sure it was set equal to 0, your inequality equal to 0. We factored, and then we solved. So this would give you -1, this would give you a +1. And then what we did is we made a number line. We had -6, we put an open circle on -6. And then we put on 1, we put an open circle because it was greater than. If it was equal to, then we put a closed circle. And then we found test points. So we picked a point to the left of here, let's say -7. We picked one in the middle, 0, and we picked one at the end. And then we plugged it in. If it made the equation true, we shaded it. If it didn't, we did not. And then we put it in interval notation. So that's what we're going to do here. Now, I want to show you what it looks like when you're looking at a graph. Okay, when you have a rational expression like this and you graph it, this is the graph that you have. So if you're looking for intervals when f of x, whenever you see f of x, that means basically the graph. So you're looking when the graph, the domain, the intervals, where it's greater than 0. Okay, so if I'm looking when it's greater than 0, 0 is right here. So where the graph is above 0 is here, here, and here. So I'm asking for the intervals, I'm looking at the x-axis. So really you can see that we have an asymptote at -3. So like right here, we have one at -3. We have an asymptote at, let's see, 2. So I'm going to put a 2 up here. Okay? And so where this graph is above 0 is going to be from -infinity to -3. It's also going to be positive. Remember, we're looking at the x's starting here, which that is -1. So -1 to +2. And then it's also increasing starting at this point, which is 4 to infinity. So those are the intervals where the graph is greater than 0. Now, if I'm looking for the intervals where it's less than 0, then that means I am looking at these bottom parts. And there's only 2 places where the intervals are going to be less than 0. So from -3, and that's -1. And then between here and here, and that's 2 and 4. Now in your assignment, we're not going to do it by looking at a graph, we're going to do it algebraically. So these are the steps on how to solve for these inequalities. So step 1, you want to make sure all terms are on one side and the inequality is set equal to 0. So the inequality, you got 0 on the right, you got your numbers on the left. Step 2, you're going to find the zeros of both the numerator and the denominator by factoring. Well, this is not factorable. So what we're going to do is we're going to take x plus 5, we're going to solve, which gives us -5. And then we're going to solve for the denominator, which if we solve for this, we get x equals -2. So we have -5 and -2. Those are our solutions. Now, what you need to understand is on a rational function, this denominator, when we graphed it, was always your vertical asymptote. This was your x-intercept. This was your vertical asymptote. Remember, your vertical asymptote, x cannot equal that number. So this inequality happens to be greater than, which means it'll be open circle, but if it was equal to, your bottom number will always, always be an open circle. So when you look at this, it tells you asymptotes are always get an open circle. So your denominator always gets the open circle. Okay? So now we're going to go on the number line, and we're going to plot -5. We're going to put an open circle and -2. And like I said, both of them are open circle because the inequality is just greater than it's not equal to. So now the next thing is, number 4 says choose test points in each interval. Substitute test points into the function and determine whether the interval is positive or negative. So let's go ahead, and I'm going to pick a number. So I'll pick -6. That's to the left of -5. In between, I'll pick -3. And then right here, I always love to pick 0. So now I'm going to plug these into this rational expression here. If my answer is greater than 0, that will be shaded. If it's not, then I don't shade there. So when I plug -6 here, I have -6 plus 5 is -1. -6 plus 2 is -4. Two negatives make a positive. Is 1/4 greater than 0? Yes, it's positive, so it's greater than. So that means everything to the left of -4 is a solution. So I know -infinity to -5 works. Now let's try the -3. -3 plus 5 is 2. -3 plus 2 is -1. Is 2 over -1, which becomes a -2, greater than 0? No, this one doesn't work. Now I'm going to plug in 0. 0 plus 5 is 5. 0 plus 2 is 2. 5/2 is greater than 0. That works. I shade this way. So then I have union -2 to infinity. All right, let's go to number 2. Number 2, we move to all terms to one side. We have that. Step 2, find the zeros of both the numerator and the denominator. Well, I have to factor first. So this would be x minus 6 and x plus 1. So my zeros are, the numerator is just going to be 0. My denominator, if I solve this, I'm going to have 6 and a -1. Remember, since this is the denominator, these are my asymptotes. They must be an open circle. But since this inequality is not an equal to inequality, everything's going to be an open circle. So now we're going to plot these on the number line. So open circle on 0, on -1, and then on 6. Step 4, let's choose our test points. So to the left of -1, I'll try -2. In between 0 and -1, I'm going to do -1/2 or -0.5. And then in between 0 and 6, I'll use 1. And then beyond 6, I will go ahead and use 7. Now, when you plug this into this expression here, you can choose to plug it into the original. You could also just plug in -2 to the denominator that's in factored form. So for example, if I plug in -2 at the top, I get -2. Well, at the bottom, -2 minus 6 is -8. -2 plus 1 is -1. So that actually gives me -2 over +8. Is that less than 0? Yes, because it's negative. So this is good. So that's going to be -infinity to -1. Now, negative 0.5, to save time, I'm going to just tell you what the answer is. I would put negative 0.5 at the top. When I plug it in the bottom, you get negative 3.25. Well, two negatives make a positive. Is that less than 0? No. Now let's plug in 1. So 1 on the top. At the bottom, 1 minus 6 is negative 5. 1 plus 1 is 2. Negative 5 times 2 gives you negative 10. That is less than 0 because it's negative. So now it's union, 0 to 6. And now we're going to test 7. So 7 on the top, 7 minus 6 is 1, times 7 plus 1 is 8. That's 7/8. That is not less than 0. So we are done. Does this make sense to you? Okay, let's just do one more problem, okay? So first, let's go ahead and factor the top. That's going to be x plus 3, x minus 3. This one is greater than equal to, so everything is going to have a closed circle except for the asymptote. So if I solve this, the top gives me negative 3 and positive 3, and the bottom one gives me negative 4. That's my asymptote. That must be an open circle. Negative 3 and positive 3 will be a closed circle. So negative 4 is open, 3 and negative 3 are closed. Now next thing is I choose some test points. So to the left of negative 4 I will pick negative 5. In between these two I'll give negative 3.5. In between here, always love to use 0. And then after 3, I'll use 4. Now to save time, I will just tell you what it equals when you plug it in. So if you plug in negative 5 into this and simplify, you should get negative 16 is greater than or equal to 0. That's a false statement. When you plug in negative 3.5 into that, you get 6.5. That is greater than 0. So in between here is good. So that means we have an open parentheses, negative 4, comma, 3, bracket. When I plug in 0, that's pretty easy. You get negative 9 over 4. Oh, yeah. Sorry, negative 4 to negative 3. Thanks. So negative 9/4, is that greater than or equal to 0? No. When I plug in 4 squared is 16 minus 9 is 7. 4 plus 4 is 8. Is that greater than or equal to 0? Yes. So it would be union, bracket 3 to infinity.